This lesson is the converse of the Pythagorean theorem. It says I'll be able to classify triangles as acute, obtuse, or right by applying the Pythagorean theorem. First, we're reminded that in order for a triangle to be constructed, the sum of the lengths of the two smaller sides must be greater than the length of the largest side, or in an isosceles triangle, the sum of the lengths of the legs must be greater than the base. And so when we're first looking at our example, first we decide, do we even have a triangle? 4, 5, 6, yes, we can have a triangle because 4 plus 5 is greater than 6. Okay, so we're going to look at a couple quick checks here and just determine, do we even have triangles? So in the first one, 4, 5, and 9, well, 4 plus 5 is equal to 9. So no, we do not have a triangle here because it has to be greater. 4 plus 5 and 10. Again, 4 plus 5 is not greater than 10, so no triangle. Okay. So next we're going to look at examples of classifying the triangles. You can determine the classification of the triangles by comparing the square of the longest side, C, to the sum of the squares of the other sides, A and B. So let's see what that looks like. All right, so in a right triangle, if C squared is equal to A squared plus B squared, you have a right triangle. If C squared is less than A squared plus B squared, you will have an acute triangle. And if C squared is greater than A squared plus B squared, you will have an obtuse triangle. So now we're going to look at some examples. All right, so here, the first thing you do is determine, do we even have a triangle? So in part A, we have 5, 12, and 4 are given as the lengths, but you take the two smaller, 5 plus 4, and 5 plus 4 is not greater than 12, so we don't have a triangle. So if there's no triangle, you can't classify it. So then look at B. We have 6, 7, and 8. Well, 6 plus 7 is greater than 8, so yes, we definitely have a triangle. Now what we want to see is what goes here. So in other words, you take the longest side, which is 8, and you square it, and I'll write it up here. That's 64. And we want to compare 64 to 6 squared, which is 36, plus 7 squared, which is 49. So we have 64 here, and if you add this, you get 85. So 64 is less than 85, and so we have an acute triangle because C squared is less than A squared plus B squared. Okay? So look at the quick check. Determine if a triangle can be formed, and if so, classify it as acute, obtuse, or right. Okay, what is the square root of 9? If you're not sure, put it in your calculator, but the square root of 9 is 3. So we can change that to 3. The square root of 16 is 4. And the square root of 27, that's not a perfect square, but it is we can get an approximate answer from our calculator. And the square root of, sorry, I'm having trouble with my calculator. The square root of 27 is approximately 5.2. Okay, so we know that 3 plus 4 is greater than 5.2. So yes, we have a triangle. So now we want to classify it. So now we're not going to use this approximation anymore, okay? We want to, let me erase this right here. So now we want to go back and we want to use the exact numbers, okay? So we have sorry, I'm having trouble with my, there we go. Okay, 3, 4, and the square root of 27. So the biggest number was this one. So we want to take the square root of 27 and we're going to square that and compare it to 3 squared plus 4 squared. The square root of 27 squared is 27. Now we're going to compare that to 9 plus 16. So we're comparing 27 to 25, and so this is greater. So c squared is greater than a squared plus b squared, so this would be an obtuse triangle. And then the last one, again, we have 1, 3, and the square root of 10. So to determine if I have a triangle, I know this, if they're the smallest, would have to be bigger, so I'm going to get an approximate number for the square root of 10, and that is 3.2. Okay? So we know that 1 plus 3 is greater than 3.2. So yes, we have a triangle. But now I want to use, when I'm deciding what kind of triangle, I want to go back and use my exact numbers. So this was the largest. So the square root of 10 squared, I'm comparing that to 1 squared plus 3 squared. The square root of 10 squared is 10. And 1 plus 9 is also 10. So this is a right triangle. Okay, so use your calculator right now when you're, squaring the radicals if you need to, and we will talk about these a little bit later. As far as the radicals, we're going to simplify those shortly. All right, now we're going to determine the classification given an actual picture. So first we look here, and I'm not sure which is the bigger number in this first one. I don't know if this is bigger or this is bigger from the picture. It's a little bit off. I think this one, but let's check. So you're going to put that in your calculator. 3 times the square root of 5 is approximately 6.7. Okay, so definitely this is the bigger side. All right, so now I'm going to take 6.7 squared and compare it to 2 squared plus 6 squared. Now here we didn't have to determine if we have a triangle because 1 is right in front of us, so we know that we do. Now when I square this though, let me erase this. I want to use my exact number. So I'm going to be squaring 3 times the square root of 5 squared. You can use your calculator, or that's 3 to the square root of 5 times 3 to the square root of 5. Remember, multiply 3 times 3, which is 9. The square root of 5 times the square root of 5, which is 5. 9 times 5 is 45. So I'm comparing 45 to 4 plus 36. So 45 is greater than 40. So this is an obtuse triangle. Please pause the video and try and do part B. Okay, 23 squared is 529. And then 11.4 squared plus 21.2 squared. When you add them together, you get 579.4. 529 is less than, so this is an acute triangle. Right. And that's the end of the video. So this was a nice short one. Hope you understand well.